2012, number 5. The rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. At time t equals 0, when the bird is first weighed, its weight is 20 grams. And if b of t is the weight of the bird in grams, that's b there, right? Then at time t, days after it's first weighed, then the dB dt, which is the rate it's gaining weight, is equal to 1/5 times 100 minus b. Right? In other words, it's directly proportional to, the rate is directly proportional to the difference 100 minus b. Now, this might look like logistic-y, but it's actually not, right? Because to be logistic, there would have to also be a b out here. Yes? You can think about that. But this is maybe like, it's not meant to be a trick question, but it might fake a lot of people out to think that it's logistic, and it's not. And they're going to ask a question about that later on. All right, so let y equals b of t be the solution to the differential equation above with the initial condition that the baby bird at when its first weight is 20 grams. Is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? And explain your reasoning. Well, let's just evaluate the derivative. dB dt when b is equal to 40 grams would be equal to 1/5 times 100 minus 40, which is 1/5 of 60, which is 12. What would the units be? B is measured in grams, T is measured in time, so that is grams per, what is it, day? Yeah, per day. And then dB dt when B is 70 would be 1/5 is 100. Notice when the bird's heavier, the rate starts going down. 100 minus 70 is 30, divided by 5 is 6 grams per day. So, so we have faster weight gain at b equals 40 grams. We don't need to say any more. We've got the math there to back that up. All right, part B. Oops, sorry, could you see any of that? Sorry about that. Maybe I'll do B up here so you can see. Find the second derivative in terms of B, and use the second derivative to explain why the graph of B cannot resemble the following graph. All right, let's see what that looks like. So the second derivative, that's the derivative of this. And I'm going to go ahead and distribute the 1/5 through there because I don't like it like that. That would be the same as 20 minus 1/5 b, right? So what's the derivative of that? Keeping in mind that t is the variable, right? So that's the derivative of 20 is nothing. The derivative of 1/5 b is negative 1/5. But b is not the variable, so the derivative of that is dB dt. Okay? Think about that for a minute. It's because this is not like a dy dx with x's over here. It's dB dt, and it's like the wrong variable. It's the top variable. That's how we ended up with exponential growth. And so we have negative 1/5 times dB dt, which is this, times 1/5, or actually I'll write it in this form, 20 minus 1/5 b, which is equal to 1/25 b minus 4. That's what the second derivative is. Right? And they want us to use this to explain why the graph of B cannot resemble the following graph. Well, let's see. This graph looks like it's at the beginning, it's flat. So when you plug in 0 into this, we should have a slope, sorry. Let's look at it this way. This is the second derivative. So according to this, there would be, this has an inflection point at, what would B have to be? At B equals 100, right? But this graph here has an inflection point at it looks like at B is approximately 60, right? This is like a logistic one, so it looks like it's about halfway between those. So these are not the same. There's probably more than one way to justify that, but that seems pretty clear to me where the inflection point is. All right, use separation of variables to find the solution to this. The particular solution to the differential equation with initial condition b of 0 is 20. Okay, so let's see if we can do that. Separation of variables. Let me go onto a different sheet here so I have a little bit more room. So we're starting with this. dB dt is equal to, I'm going to write it in this, I like it better like that. Now remember, when you're separating variables, you cannot separate by adding and subtracting. You've got to move this whole thing. So that means we're going to have 1 over 20 minus 1/5 b dB equals dt. I know it's tempting to just move that, but you can't. You can't move things by adding and subtracting. If you made that mistake, you need to pause right now and try to finish it from here. Okay, so you're back. So we're going to integrate both sides. The antiderivative of this, it's just a b here, but there is a negative 1/5. So I'm just going to write out the u substitution to make sure we don't mess up. So u would be equal to that, and that means du would be equal to minus 1/5 dB. I don't have a minus 1/5 here, so I need to put that there, and that means I need a minus 5 on the outside. So this side turns into minus 5 times the integral 1 over u du equals, and then this is just t plus c over here, right? So the antiderivative of 1 is t, whatever that variable is. And so this is negative 5 natural log u, and the u is 20 minus 1/5 b equals t plus c. I'm going to get the negative 5 over to this side, so that's natural log 20 minus 1/5 b is equal to negative 5, I'm dividing by negative 5, so there's negative 1/5 t, and dividing c by negative 5, it can still just be a c. Then I'm going to do e to the, that gives me 20 minus 1/5 b is equal to e to the negative 1/5 t, and when we have the plus c up here, it can come out here as a constant. And maybe now would be a good time to solve for c. So I know that we have the point at t equals 0, b is 20 grams, right, when the little baby birdie is born. So plugging 0 into this, I just get, this all turns into 1, and I just get c here, and then plugging 20 in over here, 20 minus 1/5 of 20 is 4, right? So that means c is 16. So that gives me, let's see, 20. I'm not skipping any steps here because why would you? 16 e to the negative 1/5 t. So trying to solve for b. Let's see, if I add this over to this side and subtract this over here, that gives me 20 minus 16 e to the negative 1/5 t equals 1/5 b. So b is equal to, multiplying both sides by 5, 100 minus 80 e to the negative 1/5 t.